A timekeeper at an athletic competition is sitting at the finishing line of the 400-meter race and presses the stopwatch when she hears the starter pistol. Calculate how many seconds her timekeeping will deviate from the correct reading if the speed of sound in air is 340 meters per second. So let's make sense of our situation. We have a 400-meter race. Let's take this point as our starting point and here as our finishing point. So this is 400 meters. Let's read through the question statement again and make sense of the situation we have. So a timekeeper is sitting at the finishing line of the 400-meter race. So if the race is starting here, this is where the timekeeper is, at the finishing line. Okay, she presses the stopwatch when she hears the starter pistol. Calculate how many seconds the timekeeping will deviate from the correct reading if the speed of sound in air is 340 meters per second. So this is where the sound is originating, at the starting point, and the timekeeper is at the end of the 400-meter race. But we know fully well that the speed of sound in air is finite. It takes some time for it to travel through air. So how much time does it take for the speed of sound to reach the timekeeper at the finishing line of the 400-meter race? That's what we are interested in. Calculate how many seconds her timekeeping will deviate from the correct reading. So let's go ahead and calculate that. We have the distance, 400 meters. We have the speed of sound in air, 340 meters per second. We are interested in the time. So what do we do with these variables? We know that the distance is equals to the speed multiplied by the time. If we want to find the time, we can just use this equation. Or you can make delta t the subject of the formula first. But anyway, let's just go ahead and substitute. The distance, 400 meters. The velocity, 340 meters per second. And we're interested in the time. Now it's just a matter of dividing both sides by 340 meters per second. And we get 1.18 seconds. So the timekeeper will only start the timer after 1.18 seconds has passed. They're already running in 1.18 seconds, and that's the only time where the timekeeper will start the timer. So it will deviate from 1.18 seconds. So let's say maybe a person takes 10 seconds. I'm not quite sure how much time people usually take in a 400-meter race. Let's say 30 seconds. If you take 30 seconds, you'll find that the time on the stopwatch, delta t, will be equals to 30 minus 1.18 seconds. This is because the stopwatch is behind by 1.18 seconds. So if you take 30 seconds, the time recorded will actually be 30 minus 1.18 seconds. We have a sound emitted with a frequency between 23 and 54 kilohertz. And then the first question, give one word for the sound with this frequency. 23 to 54 kilohertz. So this is ultrasound. So there we go. We've just answered the first question. And the second question, give one other uses of sound with these frequencies. So what are the uses of ultrasound? We talked about that in detail in previous videos. We talked about the use of ultrasound in medicine and the use of ultrasound in the industry. In medicine, it is used to produce a scan during pregnancy. And then in the industry, it is used to clean optical equipments. There we go. Longitudinal waves, past exam questions.